Okay.
This is WZRD Chicago 88.3 FM. And we have with us an old friend of WZRD, Andrew Jacobson. Welcome, Andrew. How are you?
Good. Thank you. Nice to be here. It's only been 38 years or something like that since the last time I was on WZRD, so it's nice to be back.
Yes. Well, it's wonderful to talk with you about what was the wizard like in 38 years ago.
You want the unvarnished truth, huh?
Yes, please.
Well, I mean, I was at WZRD from 1980 through the end of 1985. I guess maybe I can't even remember if I was there at the beginning of 1986 or not. But during that period of time, it was actually kind of a pretty significant transition that happened, which was partially because we went from 10 to 100 watts. But, it was a lot of fun. Everybody there was great. We had, I think that the staff as a whole really were, kind of a big extended family. And, some of us are still friends. Probably many of us are still friends. I don't know who else the people are friends, but it was very informal, as you would anticipate with a 10-watt educational radio station in late 70s or early 1980s. We did not have a whole lot of expectation around how we would operate as a, big city radio station. So I think that the station started out with a lot of people who really just decided they wanted to play some great music and they wanted to put out really good information and provide a service to the community, and figured out ways of doing it with basically no budget and just very minimal support from the university and from student government. But I think that there is a few principles that got established, and this was mostly before I joined. In fact, I would say it was entirely before I joined. And those included that, we were not here to play the same music you're going to hear anywhere else, and that we're not here to provide the same information you're hearing anywhere else. We wanted to be educational, and we wanted to be entertaining, but by showing people things that they would not otherwise have. So there was a expectation of everyone who joined the station that they would adhere to that idea. And also, no one ever said their names on the air. You're saying my name is the first time it's ever been said on the air. And
All right now.
so, there was an attitude. We had a pretty significant idea about how we wanted to be as a radio station. And I think that that was really, really strong. And I honestly can say I don't know how things have transpired. I left Chicago in 1986, and obviously there was the outage, and there was various different political machinations that went on. Not to say that we didn't have politics during the time that I was there, but I honestly don't know how much that's been kept in terms of the history of the station.
The basic tenets are still there. It's freeform, anonymity, and also we, as a community of wizards, apply our various skills to help the station. We do what we can, our strong points, and then whatever we're strong at, and that would help the wizard, then we do it. And it's very gratifying, and and our listeners enjoy it too.
Yeah.
Oh, when you were at Wizard, so were you how many listeners approximately? What was the coverage when it was a 10-watt station, would you say?
I mean, it was weak, right?
Mhm.
So you could hear it in the neighborhood. You could certainly hear it in, the northwest side of Chicago, but you couldn't really hear it when you got anywhere near downtown.
Mhm.
And you couldn't really hear it out in the suburbs too terribly far. But you can always find a way to kind of pick it out through the static and the noise and so forth. If you really, twisted your antenna to a certain direction, assuming you had an actual proper antenna, people would have a stereo with a big T, FM antennas that they would tape up to the wall somewhere. And if you pointed it at just the right direction and held it, you could probably hear the wizard, maybe even 7 or 8 miles away. and that was actually okay because we covered a lot of the north side of Chicago and a lot into the suburbs. Um, when we went to 100 watts, I would say that all became a much more peripheral experience because in the areas that we previously had coverage, we now had stronger coverage. We now could be heard actually without having to hold the antenna. Maybe you'd still have to twist it a little bit, but you could at least hear it. It was a mono station, and so operating in mono, we actually got a little bit more clarity because the stereo subcarrier adds a little bit of noise or added a little bit of noise, such that if you were in a real peripheral area, being in stereo actually made it worse. So being in mono sort of just concentrated the power. And so it was a little bit easier to hear as a mono station than it might have been otherwise. But still, the coverage is not different, you know, in terms of where the core listenership is than it was. I do think that some of the other things that have happened in the environment, you know, WHBK moved their frequency. They used to be at 88.3 and they moved to 88.5. And that, I think, cleared out a significant amount of interference such that the Wizard could be heard a little bit better throughout the, you know, west side and possibly even near downtown. And that was not necessarily anything to do with WZRD. That was because of other, you know, changes in the environment.
So WHBK was actually on the same frequency as us, 88.3.
That's right.
How did the FCC allow that?
Oh, funny you should ask that question. So if you look at the history of educational radio, when the FCC created a program to allow for 10-watt radio stations, they basically said, you know, your high grade listening area, and you know, and they would have maps, and they still do, you know, where they can say, you know, what your expected effective radiated power is at a certain distance. We draw a contour on the map, say here's your A grade and your B grade, and your decent quality in your peripheral listening area. And they would allow stations to basically touch each other with the contours. So you'd say, okay, if you were to draw a big circle around where WHPK is in Hyde Park, and a big circle around where Northeastern is, where WZRD is. And you say, well, they don't really overlap. The grade B range doesn't really overlap so much on the contour map. Approved, go for it. You know, put yourself on the air.
Mm-hmm.
It never worked like that because RF radiation doesn't just drop off suddenly at a contour line and say, fine, I'm providing no interference past this point. So everybody interfered with everybody else. And Chicago is maybe not unique, but it's certainly one of the cities that has the worst crowding of small stations into the area. You know, you have what is WCRX today. At the time that I joined, it was WUIC, which is an 88.1 FM. You've got WZRD right next to it, 88.3. I forget what there's another station, 88.5, that's somewhere in the northwest suburbs, I think. There was WMTH on 88.5 in Main Township. You have WOUW at 88.7, which benefits from having a much, much taller building that they transmit from. And so therefore, they really have a much stronger signal, such that even though it's a couple channels over, you know, on a radio that doesn't have the ability to discriminate that well would cause significant interference to WZRD, and to a certain extent, vice versa, and so on and so on. Most other cities don't have stations packed in literally every single frequency you know, that is there. So it was quite a mash in terms of you know, propagation of the radio station. And there's lots that I could tell you about. There was a consortium at one point that was created called the Chicago Educational Radio Consortium, which was essentially all these stations got together and started talking to each other. And the reason that they did that was because I think it was about 1982 or 1981 or so, the FCC made an announcement that they were now going to basically change the rules to say that every station that was at 10 watts had to either increase to at least 100 watts or accept all interference that would come from any other station, essentially saying your contours don't mean anything. Somebody could set up a 50,000 watt radio station on your frequency and completely blow you out of the water. You wouldn't be able to be heard down the hall from where your transmitter is. And so all the 10-watt stations in Chicago realized we're in trouble because somebody could land on our frequencies and we don't want to disappear. So we all have to become 100 watts. But that wouldn't work because they were already too close together at 10 watts. So there was a discussion group that was created amongst these radio stations to say, hey, how are we going to coordinate this? How are we going to all increase our power to 100 watts when we're already short spaced at 10 watts? So that played out over a period of years and led to things like WHBK moving to 88.5 because it was simply, there was fewer chances of interference. Some stations stayed at 10 watts and just said, nothing we can do. We don't have the budget. We're not in a position to do it. We have no ability to increase our power. And some stations took a different approach, which is to say, we can upgrade our power, but we have to change our antennas. Instead of being omnidirectional, we'll throw most of our power in one direction to create a notch or a gap to protect other radio stations in the area. And so there was a significant amount of discussion of who's going to have to create a gap to support or allow others. And of course, nobody was willing to say, oh, I will graciously stop broadcasting in the southeast direction so that some other radio station can exist. It's like, no, you guys should move off the frequency. Or, somebody would say, we can't possibly survive this. We're going to move off the frequency. So that's what WHBK did, for example. And WZRD came through the process and basically said, there's no place for us to create any protection for anyone else. We're just going to go to 100 watts and hopefully, if WHBK is moving, then, we don't have anybody who's directly to the north of us on this frequency, and we'll do the best we can, which I think is great that it worked out like that.
So were there any notch successes?
Well, I could tell you a long story about another radio station. So just to give a little bit of context, I was the chief engineer of WZRD for a couple of years. And I did not come into WZRD as a chief engineer. I came in as just the long-haired kid who played a lot of weird music on the air. But I became the chief engineer because of my interest in all of this. But I also worked at other radio stations. I might have been, I wouldn't say completely unique, but fairly unusual in that I actually worked at 4 different stations at the same time in Chicago. And one of the other radio stations that I worked at, in fact, it was the first one that I worked at, was WMXM in Lake Forest, which is a Lake Forest College station. And long story I could tell you about how I got in there, but essentially, like WZRD at the time, they did not have a requirement you be a student to work there. I actually did wind up becoming a Lake Forest College student and wound up staying at that station for a couple of years. But they got wind of all of this early and decided they were not going to wait for the actual mandate from the FCC, because at some point, actually in 1984, the FCC started approving all of these 100-watt increases. Everybody had their applications in advance. But WMXM got ahead of the curve, and in 1980, they went and bought themselves a 300-watt transmitter and set themselves, they're an 88.9 FM, and they needed to protect WRRG in River Grove, which was an 88.9 and directly south of them. So they put up a directional antenna that had a notch in it that would essentially say, we're only going to put 10 watts pointing south, but we'll have 300 watts pointing north. So if you were to say, wow, WMXM's 300-watt station, Lake Forest, why can't I hear it in Evanston or Skokie or someplace like that? The answer is because they're only putting 10 watts pointing south, and WRRG is 100 watts. So you're not going to hear them. But if you go to Waukegan, you can hear them pretty good. And so they actually did this work, and I just, was kind of a novice who showed up there and wound up learning a lot of engineering from the guy who was designing that, who had actually put all that in place. Guy named Bruce Wagenberg, who I had listened to on the air when I was younger, and he was on another radio station. He actually was a New Trier Township High School student and worked at WNTH, which is 88.1. And I remembered hearing him when I was like in junior high school, and then I wound up meeting him in person and discovered that he was the person who was doing all this engineering work. Kind of got me into radio engineering, as a matter of fact. So I learned all about that and actually participated in getting that all stood up in Lake Forest.
Hmm.
And that was before WZRD ever got their license approved or doing any of the construction work that we wound up doing to put the station on at 100 watts.
So uh, that station got the 100
300.
300 watts before WCRD even came into existence?
No, they were 10 watts.
Okay,
WZRD on in 1974, but
right,
WMXM became 300 watts in 1980.
80. Mm-hmm.
Yeah, and that station had been around for quite some time. I think Lake Forest had that station probably for 20, 30 years, maybe longer before then, as a 10-watt station, like all the rest.
Mm-hmm. Hmm.
Sorry, it's complicated.
No, that's okay. So when there's that notch, then whoever is they notch themselves out, then those listeners cannot hear that station. Yeah, just so yeah, so that's why some stations are um they are you can't hear them. But and
Right.
yeah, oh, I'm just
Yeah.
wondering. Yeah, because sometimes I try to get WZRD and at some places and I can't. Does it matter that you were speaking a lot about the importance of a good antenna? Might it be the radio equipment that has to be better in order for or is it once the radio equipment is better, then the antenna in the radio is also better?
Yeah. Well, it's many things. I mean, it's kind of everything. You know, your weakest link is your weakest link. But
Mm.
there's one thing that's more important than anything else, and that is antenna height.
Oh,
Those with a tall building are especially blessed. And Northeastern, the classroom building is only what is it? It's 4 stories, right?
I
And
think so.
yeah, and so that's as blessed as WZRD is. WLUW has that tall building on the lakefront, and their antenna's on the top of that.
Mm.
And boy, does it make a huge difference. It really, really was a significant difference. And it's really true. You know, you have some radio stations that are on short buildings, like WMXM in Lake Forest was on top of a relatively low building. And actually, the administration of the school at one point moved the antenna to even a shorter building, to really just the top of a 2-story building, which created a huge amount of complaint, uh, actually by me and several other the people at the radio station who understood this. But the administration did what they wanted to do. And so that actually significantly decreased the ability for WMXM to get, to be heard in the periphery. But ultimately, when you drive around Chicago and you hear called picket fencing, where you're just driving and you hear like little bits of static that chop up here and there, you hear all that choppiness. It's caused by the fact that the antenna isn't high enough. And so the signal is being basically clipped by buildings that you pass on your way.
Mm.
And not only is it getting clipped and reduced by the buildings, but it also reflects off of other buildings. And so you have a problem with reduced signal and multipath and so forth. And that's what really creates that sort of choppy sound when you're driving. And I'll tell you what, it was a whole lot worse at 10 watts. When we got to 100 watts, it really significantly improved that. But the other part about the antenna, therein lies quite a story in and of itself. So I don't know how much you want to go into the details of the engineering of this, but I'll try to be quick and I'll try to explain this as best I can. Um, when the FCC licenses a radio station, they license it at what's called effective radiated power. And that's true for any station above 10 watts. At 10 watts, it's basically whatever your transmitter puts out. Your transmitter power output is simply 10 watts, but you can put that into any antenna at whatever height that you were originally licensed for as a 10-watt station. So WLUW was on top of a tall building and had a multi-bay antenna. WZRD on a shorter building with a 3-bay antenna. I don't know actually how many WLUW has. And the number of bays on an antenna, they're also called radiating elements, actually determines how much effective radiated power a radio station has. Each bay of an antenna puts out about 50% of the input power. So if you have a single bay antenna, you're going to get 50% of the power you're feeding in as effective radiated power that you're pushing out to the community.
This
Two bay antenna.
this logo on my shirt, are these the bays?
I think they might be. I think they might be. But if you look carefully at the roof of the building, you'll see what's essentially a two bay antenna. It's got two radiating elements on it.
Mm.
But the antenna that we had at the time was three. And so when we, as a 10-watt station, we were actually getting 15 watts of effective radiated power, approximately. There's a certain amount of power loss in the power lines and so forth.
Mm.
So people would say, okay, we're licensed at 10 watts, but we're putting out 15 watts. But when we got to 100 watts, we had to be at effective radiated power of 100 watts. Well, the management of the radio station at WZRD, very forward thinking, and really, I think, decided they were going to do the best they could for the station. They got wind of the FCC's expectations about requiring stations to upgrade to 100 watts. They didn't put their application in yet, but they went and bought a 100-watt transmitter when they had the budget to do so, and they squirreled it away. That was a good idea because station really needed to make sure that it had the transmitter ready at the time that the FCC started approving applications. They didn't want to be caught short. Once you get approved, you have 1 year to build your radio station. If you don't actually get it done in that period of time, you can apply for an extension, but you could wind up losing your license if you did not get things together. And of course, budgets being what they were, student government budgets and so on, WZRD said, hey, we have an opportunity to do this. Let's buy the transmitter. And we are protected because we don't have to worry about that budget cost to get to 100 watts. Therein laid a problem that was not detected for several years. They bought a 100-watt transmitter. We had a 3-bay antenna. That would give you 150 watts. How are you going to fix that? And the answer is, there was no good answer. The transmitter itself was not capable of having its power reduced below 100 watts. It had an operating range, and to get it down to 70 some odd watts, it would be necessary to get to 100 watts. You have to allow for a certain amount of line loss. It's not exactly 50% per bay, but it depends on the wiring and so forth. You get about 50% efficiency. So something like 77 watts would have been the right power to be able to feed it. Transmitter wouldn't do that. So we had to actually take one of the bays down from the 3-bay antenna that was there. And the 3-bay antenna had been purchased when the station went live in 1974 from a company called LPB. LPB stands for Low Power Broadcast. There's a lot of people who would refer to it as Let's Play Broadcast because the equipment that they made was really quite minimal. And so the antenna itself was put up with the cabling that was provided by the manufacturer. And that cabling actually became leaky over time because of the fact that this antenna is sitting on top of a building in Chicago facing, wind, snow, rain, ice, everything that would land on it. So at the time, we had to remove one of the bays from the antenna and essentially rewire the 2 bays that were remaining to be able to operate at 100 watts. We realized that we were getting leakage into the antenna with water, and also that the antenna itself was very sensitive to the elements. And at 10 watts, it wasn't so bad, but at 100 watts, it actually became dangerous because it could cause what's referred to as reverse power, which would feed power back to the transmitter and cause it to blow out. So we needed to replace the antenna, but we went live at 100 watts on February 5th, 1985. That was the day we actually launched. We had done some testing previous to that. So I can give you a couple of minor details about the actual transition to 100 watts. We started testing in late 1984. I think it was like in November or December. And the first person who ever actually broadcast 100 watts was Little Dougie. And so he was a famous DJ at the time. He had a show, I think it was called Teenage Party. I was on the air right before him on Saturday afternoons. He was on Saturday nights, 7:30 till whenever he got tired, midnight at least. And the reason he wound up being the first one is because after I was finished with my show, I would go and like do some engineering work. And I said, hey, do you want to actually try testing at 100 watts? We were ready to do it. And he jumped at the opportunity. So we had to sign off briefly so I could move some cables around and put him on at 100 watts for an hour or two to do some testing. And we did some more testing at other points in time in late 1984 and into early 1985. But we finally finished with the work and primarily the antenna changes and started broadcasting at 100 watts on February 5th, 1985. And that was our, just the day that pretty much I just chose because we were at the point we were ready and there's no reason to delay it any further. But we became very aware very quickly that the antenna itself was much more sensitive to rain and snow and so forth. It was really kind of a minimal antenna to begin with. So I went through the process of procuring a real, honest to God, professional radio station antenna and purchased a new 2-bay antenna, which got installed in 1986 to replace the old antenna. And that was an antenna that was designed to operate with 2 bays, would work perfectly with our 100-watt transmitter, and would meet the FCC licensing requirements. So that was the entire plan to get that put up. Unfortunately, I didn't stick around. And I say unfortunately because after I left, there was nobody with an engineering background who really was there at the time to deal with it. So I put all the pieces in place, and then after I left in about January 1986. I moved to another town. I moved to Ohio. I wound up going on with my life. I graduated college. I wasn't. Maybe I should have stuck around just to make sure that WZRD got its antenna installed right. But I hired the antenna guy who had done WMXM's antenna. He's a guy named Stan, the antenna man. And he had actually done a significant amount of work on either Hancock or Sears, which is, Willis Tower now. But, it was really pretty much a antenna installer for, commercial operations. He didn't really do small educational things, but we got him to do it, figuring that he would know what he was doing. He brought his crane. And in 1986, at some point, I don't know the exact date, they replaced the antenna, but it didn't get installed correctly. And this caused a very high amount of reverse power to feed back to the transmitter, which eventually blew it out and led to WZRD being off the air for quite some time. I'll just say that I wish I had stuck around and maybe I would have prevented that. I don't know. I'm not sure what would have happened, but all I can say is I do have some regrets about having left before that all got done and seen it through. I will say this, with the new antenna, it dramatically improved the quality of the signal, even though it didn't increase the antenna height at all. It was just a much, much better quality antenna. The design of it, I think, also provided much more vertical polarization. So when you think about, people don't use these terms anymore because nobody really cares, but you used to refer to circularly polarized, and you'd hear some TV or radio stations saying, yes, we broadcast circularly polarized, which means horizontal and vertical polarization of the antenna. And when you think about, most car radios have a vertical antenna on them, so you need vertical polarization to be heard in the car. The old antenna was very poorly vertically polarized. It was mostly horizontal. And this led to, it's designed to be heard at home, but wouldn't really be that great when you're driving around in a car. New antenna was designed, much more modern antenna designed to be truly circularly polarized. And it really improved the signal while driving, which of course is one of the main places people listen to the radio these days, because the internet being the internet, when you're at home, maybe you just listen to whatever you're going to stream, right? But the difference was dramatic in terms of the antenna.
You spoke earlier about our antenna being too strong, that since we, not too strong, but with the 3 bays, then it would have been broadcasting at 150 watts. Didn't you mention earlier that WLUW also broadcast over 100 watts because of their height? If that is the case, then would that be affect the FCC license if we are only in WLUW is only allowed to broadcast at 100 watts if we end up broadcasting over 100 watts?
Well, it depends on what their transmitter was. If they have a 3-bay or 4-bay antenna and they have a 50-watt transmitter, well, 50 watts times, well, actually, I guess it would be 30, 25 or 33 watts would have been the right power. I have no idea. I don't know anything about the broadcast facility at WLUW. I also don't know. Somebody, I'm sure, out there who sees this would probably quickly correct me. But I would assume that they're doing the right thing, that they have matched their transmitter to their antenna such that they're broadcasting with 100 watts ERP. I would certainly hope so. Otherwise, some point the FCC might investigate them and they'll get fined or something. But I don't know anything about their transmitting facilities. All I know is that we had a 3-bay antenna and a 100-watt transmitter, so it wouldn't have worked for us. WMXM in Lake Forest bought a 300-watt transmitter and their antenna was matched so that they had 300 watts. And, so they basically, people just have to do that engineering work to figure out how do you match the antenna and the transmitter so you have the right effective radiated power. Again, nobody had to worry about that at 10 watts because the FCC only licensed you based on your transmitter output. Transmitter can only put out 10 watts, doesn't matter what antenna. But at 100 watts and above, the FCC license based on effective radiated power, which is where you truly have to kind of know what you're doing. So it all worked out in the end, but it was kind of a circuitous route to get there. But we have, I shouldn't say we, I would say you, because I'm not a wizard anymore, had a high quality antenna mounted as high as you're going to be able to mount it and have 100 watts coming out of the transmitter. So I think it worked out pretty well.
When you say that the higher the antenna is situated, the stronger the
coverage.
Yes, coverage is generated. So, but the watts is still the same, but it's just that there's less interference, and then there's more coverage, right?
Yes.
Is what you I get it.
Exactly. Yeah.
What about
that's why all the TV and radio stations are on top of Willis Tower and John Hancock, is because they're much higher up. I'll just mention that my old friend Bruce Wagenberg, I didn't keep in touch with him, but back in the day, he also worked at a small educational television, like a private point-to-point television station that broadcast from the top of Sears Tower with 10 watts. And they could receive it at Northern Illinois University, and they could receive it in probably Rockford. They could basically get as far as you can get before you get over the curvature of the earth, because the antenna height makes a whole lot of difference. That 10-watt signal wouldn't get very far at all if it was down at ground level. And that's why most of the broadcasters in Chicago are on top of those two towers, because they need to be up high.
What about at the listener end? When I was trying to listen to WZRD and my radio that I bought from Walgreens, what if I was at ground level almost all the time, or in the basement? If I were at a higher a higher floor, would that help improve
Absolutely.
the receive?
Yeah. Well, I mean, it depends. So the higher up you are, the less buildings are in the way. And if you can actually see WZRD's antenna, you pretty much can be assured that you're going to hear WZRD, because the power really is sufficient to get you quite a distance at 100 watts. It's just a question of whether there's something blocking you in the way. And the higher up you are, the less buildings you run into. And also, if you have a very powerful station, you get over the curvature of the earth farther. So, radio stations in Michigan or Indiana on FM that you might hear are not because they're necessarily more powerful, but it's because they have a higher antenna, which gets them over the curvature of the earth. So, so really, the higher up you are, the direct line of sight is really what it's about, or the least number of things that are interfering. The problem is that that's not only true for you, but it's true for everybody else that's on your frequency or in a nearby frequency. So if you are up high, you might not only get WZRD stronger, but you're also going to get interference from every other station that would interfere with you stronger, because now there's nothing limiting them either. So, there's always a question about what's the station on the other direction that's behind you. Isn't there some religious station out in the far suburbs on 88.3? And would you wind up having that causing more interference because you're higher up?
What about in sleepy towns where there aren't many tall buildings? If there were many radio stations over there that are not situated too high, but there aren't any tall buildings to interfere, does that mean that those listeners would have a very good receive would receive a good signal?
Well, I mean, in general, yes. It also depends on, what's the geography of the land. If it's really flat, then yeah, right. You could draw a straight line. If you could look all the way off in the distance with binoculars and see the tower, you're probably going to be able to hear the radio station. In a small town, you probably will have no trouble with that. And so you don't necessarily need to be up high. But if there's any mountains, if there's any obstructions, that could be a problem. The other thing is that metal tends to be reflective. So you'd say, okay, think about small towns that may have like a farming community, might have like some kind of a grain silo or storage tower. That could wind up becoming a huge source for reflection, where you'd say you're now getting multipath. You get the station signal, but you also get a reflected copy of it from the other building that it bounces off of. And that would cause its own interference because it's out of phase with the signal coming from the radio station. The time it takes to get and hit that metal thing and then reflect off and hit you is a different amount of time than it takes for the signal to get to you directly. And that out of phase impact causes interference. So it's one of the key problems that that WZRD has, is when you get to your downtown, the signal bounces off of the tall buildings in downtown and causes horrible multipath problems, which cause it to be even choppier when you're driving around the closer you get to the loop.
Mm. So when in a farming town, if the antenna were if they were able to put the antenna on top of a silo, then that would resolve a lot of the issues, right?
That's the idea. You put it on top of the one tall building or the one silo so that there's nothing for it. There's no other thing for it to reflect off of, and you should be able to get a better signal.
And when the curvature of the Earth, so when you measure the curvature of the Earth, if we're able to like not let the curvature of the Earth obstruct the signal, is the curvature of the Earth the same everywhere on Earth? It should be, right? But is it?
I don't think so. I think the Earth is somewhat egg-shaped. I think it's fatter in the middle toward the equator than it is at the poles. So I think that it varies. It's not a perfectly round sphere. I don't know. For me, I don't really know too much about how far you can get with it, but I always like to go to the Indiana Dunes State Park and then look across the lake and see just the tops of the buildings in Chicago and realize that the entire lake is like this big, like water droplet that's rounded up because it looks like it's sticking up into the air because you're so used to seeing the buildings in downtown Chicago being like you can see the ground beneath them. You go to Indiana and you just see the buildings sticking up over the water, and it's like, why is the water sticking up and blocking that? And the answer is that's the curvature of the Earth.
Oh, wow. How well does the radio signals go over bodies of water? There's no obstruction because there aren't any buildings on water, right?
Yeah. Right. Well, it's basically in the air, so it's really the curvature of the Earth. And of course, the farther away you get, the less signal there is. But assuming you don't have a competing radio station somewhere else or other sources of RF interference like engine noise or anything else that can cause interference, you probably still could hear a radio station for quite some distance. Really, actually, even 10 watts will get out quite far if it's truly unobstructed. It's sort of like you think about the stars in the night sky, and it's like, how much power is actually getting to the Earth? Not a whole lot, but I can still see that star. And that's kind of what it's like to say, 10-watt radio station is tiny point of light on the horizon, but you can tune your radio to actually pick up that signal. and it should do so, assuming there's no other light on that frequency. Well, in this case, radio waves, not light.
If there were not too many obstructions, like no major obstructions, 100-watt station would radiate into how far from the
I don't know.
WZRD? No.
I don't know. I mean, only being, I think the classroom building's like 100 and some odd feet, not much more than 100 feet off of it's called height above average terrain. Um, and I honestly don't know how far you would get with that. But I will say that on top of Sears Tower, the 10-watt station could be heard in Rockford, and without any trouble at all. This is again an private educational TV repeater that was installed there that my friend worked at. But I don't know if WZRD could be heard in Rockford if there was no other radio stations on the dial. It's
Mhm.
just not high enough. The curvature of the Earth will, the closer you are to
Absolutely.
the Earth, the more it's going to have an impact.
What about the recent solar flares that created those northern lights? Do the solar flares, solar storms, how much do they affect the transmission of radio waves?
I honestly don't know. I'm not an expert at that. I know that they can cause a significant amount of power to go into things like transmission lines or other metal structures that could essentially pick up electrical charges from these charged particles that stream toward Earth.
Hmm.
I doubt that there's enough metal on WZRD's antenna to get a whole lot of that. Usually you hear about these being problems for things that are outside of the planet, like satellites that don't have the protection of the environment. We have this whole magnetic uh, uh, layer on the outer atmosphere that really limits the amount of these things that actually get into the planet. That's what the northern lights are, is essentially these charged particles hitting these upper layers of the atmosphere. So satellites that are outside the atmosphere are significantly more affected.
Mm.
But on the planet, what actually gets through, you hear about it affecting like large transmission lines that cover long distances. That's enough to cause significant power impacts, power fluctuations as more or less particles hit them.
Hmm.
But I don't think WZRD would be. The antenna is just simply not that big.
Yes. And when you mentioned that they pick up some of these charged particles, and you're saying that it might affect the transmission, but is there a possibility that the listeners would hear what these particles sound like?
I don't think so. Not at 88.3 megahertz.
Oh,
You probably, if you had some kind of a listening device that was tuned to other wavelengths, other frequencies, you might find some places where you could be sensitive to it. But again, I'm really not an expert at it. So,
that's
but
okay.
I'm pretty sure that FM radio is not going to be that sensitive to it. AM radio is much more sensitive to that because of the nature of the difference between AM and FM, how the signal is received. So in FM radio, the signal really is very minorly impacted by things like lightning, which is huge amount of charged particles zapping the earth. But AM, you can hear lightning for miles in every direction because your AM radio will pick up the effects of lightning on AM radio signals, or even just create its own AM radio signals. Um, I mean, it's at the frequency range that lightning will create, create actual energy is quite broad, but AM radio is very sensitive to the kind of changes that lightning causes, whereas FM really kind of isn't.
What does
So
the lightning sound like on AM radio? Does it sound like lightning
just
or is it sound
crackling. It just sounds like
crackling?
crackling. Yeah.
Mhm.
Sounds like static. Sounds like, crackling static. That's all. It does not have a big, loud bass boom
Mhm.
that you would get from lightning because it's not causing air to move. It's just, electromagnetic. So it doesn't have the resonance. I don't listen to AM radio, so I don't know how it is these days, but it certainly was that you could always hear lightning storms on AM radio.
And you learn all this about about the radio frequencies and antennas from hands-on. Did you take any courses or not? Or you seem to be well equipped to teach a course, but did you have any formal training or was it all hands-on?
Well, I did actually. Most of the meaningful parts are hands-on.
Mhm.
You really do learn from doing. But back in the day, the FCC required there be a person at every radio station who had what was called a first-class radio telephone operator's license.
Mhm.
And to get that license, you had to actually take a very technical test to be able to get it. They eventually changed this to require not as complex a test. They have a first class, second class, and what's referred to as a third class license. Third class license basically you just sign your name and send in a postcard. But one person at every radio station had to have a first class license and then eventually a second class. So I wound up going to the Omega Institute of Technology, which was a school that was set up to get people to pass that test. And I wound up learning a fair amount of electrical engineering from it so that I could pass the test. And I went to the FCC's office in the federal building and took the test and passed it. And so I had and still have that license. They don't require a renewal anymore. In fact, the license it doesn't serve any purpose because they don't require radio stations to have people with those kind of operator licenses. The third class license is basically just an attestation and a signature so that they have tracking of who's actually signed up. And somebody with third class license has to run the radio station at this point. But so I did get some training, but it wasn't like a formal academic thing. I actually am a bioscientist by training, so I went to Northwestern and got a degree in biochemistry, and then went off to UCLA and got a PhD in pharmacology. But I learned a fair amount of physics and electricity and electronics and so forth as part of my education, but it wasn't designed for knowing how to run radio or TV stations. But that one course that I took to just pass the test probably taught me more than everything else that I knew from my academics. But again, hands-on experience is what really tells you, you really learn actually what's going on.
Did you ever consider being a radio tech person for some radio station, getting a job in that field, or were you ever offered a job to work as a radio technician at some radio station?
Well, kind of WZRD, actually, I did get paid a token, a couple $100 a year, I think it was, something like that, to be the chief engineer. They needed to have some kind of a contract in place. So they gave me basically, bought me dinner a couple times, I guess. But I was paid a non-significant amount of money to be the chief engineer of WZRD for the couple years that I did so. I had thought about working in radio, but I decided that I was much more interested in biochemistry. And while I really like working in radio, and I had a great time working at the Wizard, and more than any of the other stations I worked at, I'll have to say, and I worked at several others in Chicago. Um, no, I thought the Wizard was a place that really kind of created the idea of what radio is for me. I listened to it when I was in junior high school. I mean, I kind of grew up with WZRD. Maybe not from the very beginning, but maybe about a year after WZRD went live, I started listening to it, and I really kind of adhered to the entire concept. In fact, all the other radio stations that I worked at, I never said my name on the air either, because I just felt like I should take that as the approach. And I was the disembodied voice of the Wizard, and I was a disembodied voice of whatever other radio station I was on. But no, I never actually got paid to be an engineer at any other radio station, just WZRD, and went off and wound up getting a degree and going off and working in life sciences and doing biochemistry and bioinformatics and things like that.
Mm. You mentioned earlier that Chicago is very congested with these different radio licenses. Why is Chicago that way? If not even New York could compete with Chicago in terms of radio stations?
I honestly don't know how New York is. I think New York is probably also very congested, but most other cities typically will have fewer and larger. So if you take a look at most cities will have like an NPR, so there's the educational range of the band from 88 to 92 FM, and no commercial stations are supposed to set up there. And in that area, you will usually have NPR stations, you'll have religious broadcasters, you'll have college radio stations. Most of these institutions in most cities will set up with a reasonably large radio station. Take, for example, WNUR in Evanston, 89.3, 7,200 watts. I'm not actually sure if it still is. I assume it's something like that. I also worked at WNUR, by the way, for quite a number of years. But that's what you would typically find is a big radio station with, 10,000, 20,000 watts and so forth. And they would be owned by a large educational institution. For whatever reason in Chicago, you have small stations. And I think it's because there was no big station to crowd them out. And so you have this opportunity. University of Chicago stood up WHPK as a 10-watt station, Northeastern 10-watt station, high schools. New Trier Township High School, Maine Township High School, both had radio stations. WUIC was at University of Illinois, Chicago Circle Campus, as we used to call it back then, 10-watt station. But they were there because there was nothing, they could do it. They could have that aspiration. It wasn't that expensive to build a small radio station. And because they weren't crowded out by having a large station that just like took over that section of the dial, there was room. And I think there was an interest. I don't know, Chicago maybe, I don't know if there's anything specific about Chicago and why radio made so much sense for smaller institutions, high schools and colleges to have each their own radio station. But, I'll just give you an example. When I went to grad school, I went to UCLA. UCLA does not have a radio station. Most of the University of California schools have their own radio station. Berkeley has one. UC Davis has one. But UCLA didn't. But a small college, Loyola Marymount University in LA, stood up a radio station, and Santa Monica College stood up a radio station. There's no room for UCLA to stand up a radio station because those are very large and powerful radio stations. There's no room on the dial for it. So it's kind of first come, first serve. And if you didn't get in when the getting was good, somebody else put in a large station. You can't put something on the same frequency or even near it, not even within a couple of frequencies over, simply because as a large station, you're going to have so much interference that you would cause or receive by a station that's nearby that they just wouldn't license them like that. But 10-watt stations, they're just handing them out like candy. So I think Chicago just had a lot of institutions that, for whatever reason, got the radio bug.
You said NUR has a 7,200 watt station?
WNUR, yes.
So that means that, is that the most powerful wattage of the entire city then? If it's that.
No. Most of the stations on top of Sears and Willis Tower and Hancock are much more powerful than that. But into the educational area, I think there's a couple of others that are quite large, and there's a religious station. I forget the name of it. That is like 100,000 watts, and nothing can be within several frequencies of it. So between 88 and 92, if you just look at what's there, you have WBEZ, of course, which is quite a powerful station. WNUR is not that powerful, actually. I mean, 7,200 watts covers the north side, but then there's a station on the south side on the same frequency, WKKC. I honestly don't know if they're still there, but they were on the same frequency. And it just shows you I don't live in Chicago anymore, so I don't know the nuance of what goes on in the periphery, but they cover most of the north side and the suburbs, and you could probably even hear them up to the Wisconsin border. And again, they're on a tall enough building and they've got a powerful enough transmitter. But amongst the college stations, I think WNUR is the most powerful.
For WNUR, if since they have their 7,200 watt station, does that mean that if they were not at a tall enough building, that 7,200 watt could push the signal more strongly even past obstructions or
Yeah,
no?
I mean, it'll certainly penetrate farther. It can certainly be heard. There's less effective multipath because the primary signal is much more powerful.
Mhm.
So if you drive around and listen to WNUR, you don't get hardly as much interference as you would listening to WZRD, and it goes farther. And of course, they're on the lakefront, so they're able to be heard kind of down the lakefront because the curvature of the lake, their signal actually hits a lot of the lakefront areas better than it would if it were further inland. But in Evanston, where their antenna, I assume it's still there. I honestly
Good.
don't know. But
Oh,
during the
the
time that I was in Chicago, yeah, I mean WNUR was significantly easier to hear most places.
yeah, the WNUR still exists, of course, but I
Yeah.
don't know anything about their antenna. You mentioned that they're metal buildings, right? That would reflect the
Hmm.
radio waves. But what about, let's say, wooden buildings or concrete buildings? What happens? Do the radio waves still go around the solid structures, or do radio waves go through some uh, materials?
Yeah, radio waves don't go around. They just go straight lines, right?
Oh,
They're just like beams of light.
got
It
it.
really isn't different than that. And of course, the thicker the thing is and the more dense the material is, the more that will get absorbed and less it gets through. And
Oh.
also metal is very reflective. But I would imagine concrete is actually significantly also limits the amount of radio frequency energy that would propagate through. So very densely constructed buildings probably have much worse reception inside. They probably don't reflect as much, though. I think metal is much more of the reflective surface, just like you would think about light shining off of a reflective metal surface.
Oh, that is
Yeah,
so interesting. Uh,
yeah.
so, thank you so much, Andrew Jacobson, for joining us and discussing so much about radio transmission, which I've never even thought about before. It's very interesting, and now we know a lot about why sometimes transmission is good and sometimes we have problems.
Yeah,
And
absolutely. Well,
yeah,
happy to speak to you. It's a pleasure, and hope that this is interesting to
it is.
whoever's made it through this my endless diatribe here for the last
No, no,
what
no.
is it, like an hour or so.
It
But
is
thanks
very.
again for the
Oh,
opportunity.
yes, thank you so much. It is very interesting because even though we have the stream, we have so many listeners that tell us that they listen on the radio, not on the
Right,
stream.
the
And
old-fashioned way.
yes, but the stream is better. But why is there something in the old-fashioned way that sounds better? Anything is it? Why is there any better quality that is like that you would say on the radio versus the stream?
I don't know. I mean, you'd say, well, it's analog, but probably there's digital equipment, everywhere through the chain. But the actual FM broadcast process is still analog. So maybe there's something to be said for that. I just like listening to it in the car. I was in Chicago for the last couple of weeks, just doing other things, and it was such a pleasure to be able to drive around and listen to the Wizard again and remind myself exactly why I like the station. And it's like it's still great. It's maybe even better when I was there, and you just can't beat that. The fact that this is something that is local and you're still having to fight against the static, and for me, it's like this is your experience of WZRD is going to be as kind of this underground radio station. Its antenna is not that high above ground, so as a
Mhm.
result, it's a little bit harder to get and maintains its edge. It
Mhm.
certainly has not, to my experience, been corrupted by all the things that have kind of ruined broadcasting over the years, and obviously being a non-commercial station as well. So anyway, keep up the good work. I really appreciate it. It's nice to know that it's 50 years and as great as ever.
Yes. Well, thank you, Andrew Jacobson. Thank you for all that you have contributed to WZRD. And thank you for joining us today on WZRD Chicago 88.3 FM.
Thanks. Take care.